Recently, a discovery has captivated the attention of scientists and space enthusiasts alike. Bill Nye, the well-known science educator and communicator, made headlines by revealing that Voyager 1 had detected over 300 massive objects in deep space. This extraordinary finding has sparked intense curiosity and raised profound questions. What exactly are these objects? Where did they come from? And what do they mean for our understanding of the cosmos? For nearly 5 decades, the Voyager missions have delivered some of the most groundbreaking insights into our solar system. These 2 spacecraft weren't originally designed to survive this long. Back in the 1970s, scientist Michael Minovich proposed a revolutionary idea. Spacecraft could use a planet's gravity and velocity to propel themselves farther through the solar system. What began as a 5-year mission soon became one of the longest-running and most successful space programs in human history. Launched just weeks apart in the summer of 1977, Voyager 1 and Voyager 2 were initially tasked with exploring Jupiter and Saturn. They accomplished this with astonishing success, sending back some of the earliest detailed images and data about these gas giants. But their journey didn't stop there. Voyager 2 went on to make history by conducting the first and only close-up observations of Uranus in 1986 and Neptune in 1989, a mission so expansive and ambitious that it earned the name, the Voyager Grand Tour. And instead of ending, the Voyagers pressed forward, beyond the planets, beyond the Sun's magnetic influence, into deep space. Today, over 45 years later, Voyager 1 and 2 are still transmitting scientific data from the outermost edges of our solar system and beyond. In 2013, NASA confirmed that Voyager 1 had officially entered interstellar space, the vast, quiet region between the stars, free from the Sun's magnetic field and solar wind. It was like stepping out of a bustling cosmic city into a serene, star-lit wilderness. Voyager 2 followed suit in 2018. Crossing into interstellar space at a distance of over 17.7 billion kilometers from the Sun. These 2 aging spacecraft remain the only human-made objects to venture into this unexplored territory, studying the interactions between our solar system and the interstellar medium. One of their most significant contributions has been helping us understand the heliosphere, the vast protective bubble formed by the solar wind that surrounds and shields our solar system. At its boundary, the Helopause, the solar wind collides with interstellar particles. Crossing this region means leaving the Sun's influence behind. Voyager's data has given scientists remarkable insights into this boundary. One of the most unexpected findings is that cosmic rays, high-energy particles from outside the solar system, are dramatically more intense beyond the Helopause than within it. It's like stepping out from behind a protective wall and facing the raw energy of deep space. In 2023, Voyager 1 detected a faint, persistent humming sound, corresponding to vibrations in a sparse amount of gas floating in interstellar space. Nicola Fox, head of NASA's Heliophysics division, emphasized that the Voyager missions have revolutionized our understanding of the Sun's influence, delivering knowledge no other spacecraft could. Even more impressive is the fact that both Voyager spacecraft still function, despite running on limited plutonium power that continues to decline as the radioactive material decays. To preserve energy, NASA has had to make difficult decisions, shutting down non-essential systems, including heaters that protect instruments from the frigid environment of space. And yet, since 2019, all 5 key science instruments have continued to operate, baffling scientists who cannot explain how the spacecraft remain functional in such extreme cold. It's a testament to their resilience, and a mystery in its own right. The Helopause itself has also proven more dynamic and unpredictable than once believed. It doesn't form a fixed shell but instead shifts and distorts, taking on strange shapes and unexpected angles. Over the past decade, data from Voyager 1, Voyager 2, and NASA's Interstellar Boundary Explorer, IBEX, have revealed that the Helopause changes position and structure over time. In 2014, IBEX detected a sudden brightening of energetic particles, hinting at turbulence in the boundary. The observations didn't align with any known models, suggesting a level of complexity scientists hadn't anticipated. One of the most intriguing findings was the 6-year difference between when Voyager 1 and Voyager 2 entered interstellar space, despite their similar trajectories. These discrepancies are challenging long-standing assumptions about how the Sun interacts with the surrounding galaxy. In a recent paper published in Nature Astronomy, researchers described these inconsistencies as, entry-speaking, anomalies, signals that might rewrite our understanding of the solar system's outer limits. NASA's Interstellar Mapping and Acceleration Probe, IMAP, scheduled for launch in 2025, aims to further investigate the heliosphere and its strange behaviors. But while we wait, Voyager's discoveries continue to challenge and inspire. In May 2023, Voyager 1 experienced an unusual technical problem. The spacecraft's Attitude Articulation and Control System, AACS, which manages the orientation of its high-gain antenna, began sending confusing data. It was as though Voyager had developed a kind of electronic aphasia, unable to communicate clearly. The data appeared random and incoherent. Yet, curiously, Voyager's signal remained strong and stable, suggesting the antenna was still pointing correctly at Earth. Even more strange, none of the onboard safety systems were triggered, and all scientific instruments kept functioning normally. NASA eventually traced the problem to a computer system that hadn't been used in decades. A simple command switch to a functioning system resolved the issue. But the cause of the malfunction remains unknown. Could it have been triggered by a rogue high-energy particle? Or was it something else entirely? Voyager's computers, built in the 1970s, operate with just 70 kilobytes of memory, less than what's found in today's digital watches. Yet these ancient machines continue to send valuable information from distances where it takes nearly 23 hours for a signal to reach Earth. As they travel deeper into the galaxy, Voyager 1 and 2 face challenges no spacecraft has ever encountered: extreme radiation, unpredictable magnetic fields, and software aging at a rate far beyond what anyone expected. These risks were once unimaginable, and yet the missions endure. Let's take a moment to reflect on their extraordinary legacy. Voyager 1 and 2 are about the size of small cars, powered by technology that now seems archaic. Their analog cameras and basic processors feel primitive in the modern age. Yet these humble machines have transformed our understanding of the universe. Thanks to the Voyagers, we discovered that Jupiter is a world of chaotic storms, with hurricanes larger than Earth, glowing auroras, and thin rings once thought impossible. Saturn's rings, once believed to be simple, are now known to contain thousands of braided ringlets, delicately structured and dynamic. Even more astonishing were the surprises on moons like Io, which revealed active volcanoes, and Triton, where nitrogen geysers erupt at temperatures near absolute zero. And then there's the potential for alien life. Voyager revealed that Europa and Enceladus, moons of Jupiter and Saturn, likely harbor vast saltwater oceans beneath their icy surfaces, making them prime targets for future exploration. Perhaps the most poetic moment in the mission's history came when Voyager 1 looked back at Earth in 1990. At Carl Sagan's suggestion, it captured the now iconic image known as the pale blue dot, a view of Earth from 3.7 billion miles away, a tiny speck suspended in a sunbeam. That image reminded humanity of our smallness in the vast cosmic arena. Since then, both spacecraft have crossed into the interstellar medium, where no human-made object had gone before. Every day, they travel another 3 to 4 light seconds farther from Earth. Their signals, though faint, are still picked up by NASA's Deep Space Network, an intricate system of tracking stations around the globe. Yet as Earth becomes increasingly crowded with radio noise, detecting Voyager's whisper from the stars grows more difficult. Still, they persist, delivering data, one packet at a time, from the deep. The Voyager missions were born from vision and seized upon rare opportunity. The planetary alignment of the 1970s and 80s made it possible to visit all 4 gas giants in a single mission. A once-in-a-lifetime chance that NASA embraced, despite budget cuts and technical challenges. Nearly 50 years later, Voyager 1 and Voyager 2 remain humanity's furthest travelers, our ambassadors to the stars. They are unlocking the secrets of a universe we're only beginning to understand, and their journey is a tribute to human curiosity, persistence, and our relentless drive to explore. Let us know what you think in the comments below. Was the discovery of the 300 mysterious objects just the beginning? What else could be out there in the void? If you enjoyed this journey through deep space, give the video a like, and subscribe to Discovery at 2.0 for more stories that go beyond the stars. Turn on notifications so you never miss a moment of our unfolding exploration into the unknown.